Hi everybody. Today we're going to take a look at something called the product rule for derivatives in calculus. And it's used in applications like the one I have here. Now this is a fairly simple example because what we could do is we could distribute here and multiply this out into a single polynomial function and then take the derivative just using a basic power rule type operation. But in some circumstances that type of operation, that type of multiplication is not actually going to be helpful for us. So we need something called the product rule to help us out when we are taking the derivative of a product. And here is what I call the product rule. Okay? Now I want you to take a look here. It's saying the derivative of two functions, or the derivative of the product of two functions, u and v, both of these are functions of x, is equal to the derivative of u, or the first function, times the second, plus the derivative of the second times the first. Okay, it's just a basic pattern to follow and fairly simple to use, and that's what we're going to do here. So let's take a look. What I'm going to do is I'm going to label this first guy u and this second guy v. Okay, now when we take the derivative, dy dx, okay, that's going to equal to the derivative of u. Notice u prime, so we write u prime first, and the derivative of this is simply 1, okay, times v, which is, see, times v, which is this entire binomial written out. Then plus, according to our formula, plus, all right, the derivative of v, so notice v prime, that's the derivative of v, so this is our v, so we say that is 2x plus 3 times the original u. So we go back and multiply it times that, times x minus 4. Now in some circumstances it's actually handy to multiply this out. There will be some applications where you have to multiply this out, and still there's a little foiling to do here. For instance, you distribute and you get 2x squared minus 8x plus 3x plus 12, and that equals, and once fully simplified, we get 2x squared. Let's see here, 6x minus 8x minus 2x plus 12. I believe that's correct. Let's just double check. Oh, why did I say 2x squared? It's actually 3x squared, so let's fix that real quick. This should be a 3 here. Okay. I believe that's right, yep. And then 3 minus 8 is 5, plus, okay, good, good. And this is the final derivative in simplified form. Okay, now in class we're not always going to simplify to that point. In fact, for the most part, and even on the AP exam, this is an acceptable answer for the derivative. Okay, but there will be some applications where we do need to carry it all the way down to this level. All right, so let's take a look at a second example. And for that matter, I'm just going to copy this and bring it with us. Okay, and bring it to the next page. Here is another example. And we're going to follow the same rule. All right, we're going to, where's my paste button? Edit, paste. We're going to keep this to the side so we have it for reference. All right, once again, what I like to do is label my u, which is the first function, and my v, which is the second function. Okay, so when we take the derivative, it's fairly straightforward. So we say dy dx is equal to the derivative of this. Now remember, the square root of x is simply equal to x to the 1/2 power. So when we take its derivative, in other words, the u prime that we're trying to find, it's 1/2 x to the negative 1/2 times v, which is the original v. So we write that whole binomial. All right, so this is u prime v plus, now we do v prime, which is 3, times the original u, which is radical x. And that is the answer. Now it could be simplified, and the simplification of this is actually fairly complex, so we're not going to worry about it here. And this would be our derivative. Okay? Very good. Let's do one more example. Okay, I'm going to do our little paste here again. Bring that over just for reference. Stay there, thank you. All right, here we go. Once again, what I like to do is identify my u and v. Here's my u. It's going to be this entire trinomial here. And my v, of course, is going to be this entire trinomial. And you can see, if I were to distribute and multiply this out or expand this, it would be a fairly large and complicated expansion. So the product rule actually simplifies the process for us. So all right, remember we do u prime first. That's what I'm going to do here. dy dx is equal to the derivative of u, which is 2x minus 2x minus 3. Okay, times v. So we write out all that. 4x cubed plus 2x squared plus 8. And then, of course, plus, and then we do v prime, which is the derivative of v, and that's 12x squared plus 4x. Close parentheses, and then we write the original u. Okay? And that's really all there is to the product rule. We'll see a lot of applications of it this year, and we'll actually be using it quite a bit. So it's important that you just learn the rule, learn the patterns, and be ready to move on with it. Now, the next video, the upcoming video, is going to actually use what's called the quotient rule, where we learn to deal with a quotient or a derivative when we have to take the derivative of a rational function. All right, great job. Thank you, guys.